we're Passive House California, as we always say, which we are part of the Passive House Network and International Passive House Association, and we're connected with the Passive House Institute as well. So this is a Passive House hosted event. And I'd like to thank you to our sponsors. We have our silver sponsors, Small Planet Supply, Minotaur, and Earthbound Homes. Minotaur is about to renew. Everybody else is in there, and then we have a number of supporting sponsors, as you can see here on the screen as it is. So thank you to all of our sponsors. At this point, I will now stop sharing, and we'll turn it back to you, Kim, to organize the hello, everybody.
Perfect. Okay. Well, my name's Trent Lawton, and I'm a builder and an architect, and I received my certified Passive House design certificate in October of 2021. And today we're going to talk about my first design and build passive house that is in the process of certification. We're almost done with construction, and it's in the high desert of Southern California. And so just as a summary of what we're going to review today, I'm going to walk everybody through like the site, the context, and the weather, which is very important when talking about this job, kind of a programming and project overview. You guys can have a good idea of the component parts that make up what's happening here. And then the bulk of the presentation, we're going to jump into my initial iterations of the design, how that played with the PHPP weather sets, where I was at, and then how that design was updated to get it to kind of work with Passive House in the climate. I'm going to touch briefly on the MEP and the windows selected on the project, and then talk about Passive House and the California Energy Code reports and how it relates to a case study that's on the property, and then take questions, and happy to answer as many questions as possible. So let's get into it here. The project is located in a place called Morongo Valley, and it sits between Palm Springs and Joshua Tree. So it's not quite low desert, it's not quite high desert, mid desert, I guess you could say. But you pass through it on your way up to Yucca Valley and Joshua Tree. It sits at an elevation of 2,835 feet. And from the climate data set for the PHI, which is from Yucca Valley, we sit in the climate zone 6, hot, and then in California we are in climate zone 14. There's a lot of different numbers on the averages of the temperatures here, so I just want to touch on what we've experienced out here building this year. In July, we recorded a high temperature of 114 degrees Fahrenheit, and in January a low temperature of 22, although when there was a lot of snow down here in Southern California in 2023, I'd recorded like in the low teens at the job site at night, of course. You can see I've provided a some path diagram to kind of illustrate that there is nothing on the site hindering or providing any shading or really any obstruction to the solar potential, which is fantastic from a solar aspect. Not so great from the thermal envelope that we'll talk about. And then a windrows here. So for, we get a lot of wind directly out of the south here for about 9 months out of the year. And then the northeast in the summer, in the wintertime, which plays a part in how the project is situated, because the wind does blow quite frequently here. So it's very important for the client to have outdoor spaces that they could enjoy that were protected from this space. And then I've included a little snippet from the weather charts from that climate data set down below for your reference there. I'm going to jump into the project site here. So I'm showing a survey. It was initially a 5-acre parcel that was subdivided into 4 parcels. This was before my involvement in the project. So each site ends up at about 1.15 acres after street dedications and things like that. The site that we're going to talk about today is in the southwest corner and highlighted in red in the center there. And then if you look down at the lower left corner, there is an aerial shot, I think from when they sold the property, showing the lots from the south. One thing to note that in the southwest corner of this southwest corner lot, there's actually a drainage easement from the county, and you can see that kind of shown in that lower left-hand corner. And when it rains out here a lot, that turns into a 3 to 4 inch deep river of water. So while we don't get a lot of water, when it does rain, it rains a lot and it moves dirt and things around quite quickly. The other two photos that are shown here is kind of from the center of the site to give you an idea of what it looked like when we showed up. Lots of cholla, Mojave yuccas, creosote plants, and other lovely bushes that are around. We sit at an elevation band where there are not naturally occurring Joshua trees. So there were no Joshua trees anywhere on any of these parcels, which if you've developed out here, that's something that you need to be very sensitive in dealing with. So we got away with having to really deal with those. And then the primary view to this south at the north face of the San Jacinto Mountain, which in the wintertime, it fills in with a bit of snow, as you can see here, and it's quite a wonderful thing to get to look at every day when you're working. Feel pretty lucky for that. Here is another just kind of contextual shot. This is taken about 2.5 miles away up a trail behind the property. So at about 4,600 feet is where I'd be standing when I took this photo. And looking out towards, you can see San Jacinto in the center, Palm Springs and the low desert cities are down there, the Salton Sea kind of to the left. And there's a bush, I'm not sure if everyone can see my cursor or not, but the site lies down there in Morongo Valley. So it's quite a rugged, mountainous, beautiful place to build, which is great. But from a weather aspect, it makes things a bit difficult. So at this point, we're going to jump into the program for the property. So what I'm showing here is it's a landscape sketch that I put together for to get some planting plans, but it's the most recent kind of site plan that I put together for this property. North is facing up if you can't catch the arrow down below. And for this project, you enter from the south off Recuerdo Lane up a long driveway. It's about 170 feet to the carport. And the reason the project is located there is when moving around the property, initially, that is the one spot that you get the most exposure to that wonderful view that the client wanted to see. So that's kind of why it's there, and rotated 12.5 degrees off of south because that's what you need to do to not look at the power pole and actually see the view. So when we were grading the lot and setting the profiles, we actually rotated the project in order to maximize that view there. So when you kind of come up the driveway, you enter in at a 2-car open air carport that is, got 730 square feet of parking and a roof that cantilevers into the backyard to provide a bit of shade for their cocktail pool that's in the ground back there. When you get out of your car, you enter in off this main large pad into the 3-bedroom, 2-bath house with the primary suite on the western side and the 2 bedrooms in the Jack and Jill bathroom on the west, with kind of an open concept main living space with matching sliding doors on the north and south to take advantage of that view and kind of open that space up. That is the passive structure on the property. That's the only one that's, working towards, certification there. The other 2 accessory structures in the bathhouse and the pump house obviously are not, but the bathhouse is where the laundry and the water heater and the fire sprinkler booster tank is located, along with an extra toilet. There's an outdoor shower and a tub. Doesn't relate too much to this conversation, but that's why it's termed the bathhouse. And then the pump house is we built around the well that was drilled prior to us beginning the removal and recompaction and grading process on the job, which provides extra storage and a place for those systems. So this property, being where it's located, has access to electricity, but obviously not water or a sewer system. So we have a well on the property that was drilled at 420 feet before we reached water there. And that system includes an underground storage tank, which sits to the north of the pump house, below where an outdoor dining table will be. And then we provided a booster pump in the pump house that it gives the domestic water pressure for the house. To the south of the house, there's a larger cleared area that you can see kind of next to the additional parking in that diagram. where the septic tank is, and then the leach field is in that area. So we had to clear that out, and that's where we installed the leach field. And one final site system that we had to implement was a like freestanding 5,000 gallon water tank with a 4-inch hookup for the fire department. So when they come out there, they can use it to fight wildfires or put a fire out at the house. That is in addition to the fully sprinkled system inside the house. And that's something that's contingent to Morongo Valley, not necessarily Yucca or other places in San Bernardino County. I'm now going to jump into take a little bit of a step back to some axonometric views of the approved design development from the client. And it's the same component parts. You can see a main house, a carport, and the bathhouse. At this stage of the job, the pump house was not included. That was built and added later in for well protection and things like that. But this is where my initial inputs into the passive house planning package started. And while I was working through the design of this house, I was going through my certification process. So to say that I was new to PHPP and passive house would be an understatement. And so when designing these houses and setting these parts, what I was trying to do was follow case studies that I'd looked at, obviously in different climate zones, and some of the basic principles of passive house that were taught to me. So a more kind of compact footprint that you can see in the main house, separating my systems outside of the thermal envelope where I can, and also, giving them the outdoor, area that they wanted to have, separating the carport from the house and trying to make some simple tasks that I could get and keep my glazing percentage not low, but, not an extreme amount of glazing, and concentrating it on the north and south elevations and trying to put the least amount of glazing on the east and west as possible. So essentially, I have windows into the bathrooms on the east and west, and outside of the front door, those are the only penetrations that you'll see in the building. Another thing to note is the extensions of kind of the wing walls, which pick up the beam on the front. That's for strictly when we started for wind, right? And the way this is situated on the site is to kind of create a northern wind protected courtyard. So that's kind of what informed the placement of these parts, which was taken care of in like the master planning portion well before getting to this point. So you can see here, we'll flip to the next slide, a floor plan of the house might help a little bit. And again, the same component parts here. So you enter in from the western side. There's a small ERV and electrical room with the ducted mini split there. And the primary suite on that side of the house, walking into the main open living space, and then with the 2 bedrooms and the Jack and Jill bathroom on the eastern side of the house. And when I had gotten here as well, plugging in and thinking about assemblies and R values and things like that, trying to get what would be more of a standard set that I had been shown and seen. So that's why I ended at an R30 slab, 6 inches of foam at this point in time, walls around R50 with the overframing on the interior, some deeper inset windows and things like that, and then an R value of 62 on the roof. And on the next slide, we can kind of look at a long section of this iteration. So south is on your right-hand side, and will be as we continue through here. And you can see my slab assembly of 6 inches of foam. I've got my gravel down there, a 2-inch by 1 foot footing, thickened slab edge, and utilizing ICF blocks to create my stem walls. And also, with the double stack of that, allow my framing to be above grade by more than 8 inches, allowing the client to have the kind of seamless in and out look here. So this is where I was when I began putting everything into the PHPP, and thinking that, in following the steps as best as I had learned, that I was setting myself up for success. And so after inputting all these things and kind of going through this stuff, I realized that I was pretty far off. So we'll go back to the section, but I'll just take a look at an initial verification page. Now this is from the current one with the shading out, but the numbers are relatively similar. And you'll notice I have the cooling and dehumidification demand at 7.81 right now. So not anywhere close to where I would need to be. And so I felt a little bit distraught at this point in time, and even more distraught because before I had the Yucca Valley climate set, I input Palm Springs and it was at 10.8. So much larger than it was then. And, you know, a bit, you know, distraught in that sense, right? You go into something with the best intentions and a little bit of experience and think you can, you know, knock it out of the park, right? And you kind of run into a wall here, which is okay. That's a part of the process, but certainly something to learn. So I went back and I'm thinking to myself, okay, well, what can I do here? I've got my PHPP set up. What if I just start like cranking the dials in here? What if I make the slab an R70, right? Which is ridiculous to think about, but you can use the PHPP to input whatever you want and check the verification pages and run through the tabs to make sure that you're within where you are. And I could crank the insulation on all these walls to ridiculous amounts, and it was not moving the needle anywhere enough to make a difference. Start pulling windows out of the project, right? Let's just take half the glazing out. Let's take all the glazing out and see what happens. And still, you know, with an entry door and a couple pinhole windows, like still not there. Well, what happens if I take my, you know, south overhang and increase that to 15 feet or something ridiculous? Still weren't quite there. Everything helping a little bit, but certainly not getting you there. And obviously to think of a, you know, 15 or 20 foot overhang on a 1,100 square foot house would be a little ridiculous. But point being, it was a helpful tool to be able to just see what can be done, right? I mean, it may not be the funnest tool to work in spreadsheets. I enjoy spreadsheets, but still you have the ability, once you have your metrics in there, to kind of see what you can do, right? So stumped and stuck right here, and we're getting close to, you know, we're through permitting and working on this stuff and thinking about you know, where can I go next, or in the permitting process. I had to take a trip down to Morongo Valley to clear the driveway and get ready for the well company to show up. So I took that trip down there, and on my time down there, I would travel between Morongo Valley and Yucca Valley a lot. And when you're heading up that grade, for those of you familiar with the area, I noticed these two structures sitting up on the hill. And I thought it was interesting because, I mean, they're just different. And this is from across a shot from across the road, and then one kind of zoomed in. And I would look at them. I drove up and down over the course of a few days that I was there, and I'm kind of looking, going like, that's really clever. Like, it's really hot here, and everybody knows that when you're in the desert, shade is everything. If you're standing in the shade or in the sun, you know, on a 108-degree day, like, it's still hot in the shade, but it's much more tolerable. And I was thinking, I'm going, well, that's really clever. It's separated from the thermal envelope, right? So you're not dealing with overhangs that might be potential thermal bridges, which I have on the north and south in the last section. And, you know, what would happen? So I finish my trip and I go back and think about, what do I do next, right? And how can I try to make this work, and what things can you do? And so that's when this kind of inspiration, right, was what led me to starting to play around with like exterior shading of the roof. And so in my areas tab, I began to crank my shading reduction factors on my roof to a point of like, what would happen if I just put it at 0.01, and I put it at 0.01 and got a big jump in the numbers. And at that point saying, okay, well, that's pretty cool, but it didn't quite get me all the way there. So we got to crank some other dials. What other dials can I crank, right? And it wasn't anything to do with the insulation or the windows or anything like that. Making the roof bigger certainly helped, and shading the structure certainly helped, but it wasn't quite there. And then worked into, you know, exterior shading devices on the windows. And so every window on this project, outside of one north facing entry right when you enter, has an exterior shading device on it, right? So inputting these numbers, looking at it, I go, okay, I'm, staring at this PHPP verification page you can see here, and this number's dropping down, it's dropping down. And when I put the exterior shading reduction factor to 15%, which is essentially blackout shades on the windows, I was able to comply, and not by a lot, but I was in compliance. So there were still other items in the house that kind of needed to be fine-tuned through that process to get there. But that was the moment. Now, there's a big step between, putting numbers into the PHPP and seeing, if I put a 0 here, like, what does that do? Or what's this there, that are both design elements and cost elements, right? So then you kind of have to take a step back, or I took a step back at that point in time and go, well, what can I do? So if I go back to this initial axonometric, and I apologize for jumping around, you're seeing 3 structures here. And I think I have some corrugated metal roofing. I've got like a fiber tight roof and as monolithic plaster walls and these parts that didn't really tie together. And so when thinking about it as a design process, I go, right now I feel like I have 3 parts that are just separate. I've got like a CMU wall thing with metal roof and exposed timber. I've got a bathhouse that's corrugated metal on the outside and a roof. Those kind of don't play together. And you have this main house, which is like this monolithic plaster kind of Southwestern style thing. Like nothing was really together, right? And so that's when I kind of looked at it and said, okay, well, what happens if we take these elements of this kind of corrugated roofing system and create a shade roof over the house, essentially, right? Taking the same construction that I would be using for the carport over roof and the bathhouse, pergola roofs, and apply that to the main house. And that's where I kind of got here. Now we're looking at a further iteration later on. The treated floor area has increased. When we were doing the foundations on the house, the client opted to widen from east to west the property by 8 feet, which is not a small amount, it's a little bit. So my treated floor area jumped up. And the carport got bigger. And obviously we have the addition of the pump house, which isn't pictured here. And this is where the design kind of kept to something that was tying all these buildings together, helping out with my passive house package and getting me into something that I could begin to say could be certified, right? There's a big step between having a verified PHPP and a completed project with an air tightness test on it and everything documented properly, but certainly in the right direction. And again, same idea as north and south windows. The design did not change a whole lot. It's just more the detailing and adding this over roof on there, which is, it's a 3,000 square foot roof on top of a 1,265 square, treated floor area, obviously with thickened walls and things like that. My gross square footage on the house is much larger than that, but still a large idea. The plan is largely the same here. The carport's bigger, as you can see, but the layout is the same. It's wider from the east to west now. The bathhouse is the same. The stuff is all similar, right? And with the addition of this shade roof. And you'll notice that there are differences in the R values on the house. So now I'd like to take a look at the updated section for this one. And again, south is on the right-hand side of the page, and I apologize for not having an arrow for that, but we'll kind of work through the assemblies of this section here, and I'm going to start from the top down. And assembly A is the shade roof, which consists of 7/8 corrugated metal. They decided to go with a rust steel metal, which can be a challenge in mitigating and collecting the water in gutters, which aren't depicted on this section. But there's that corrugated roofing. I've got 3x4 purlins, as you would call them, laying on top of 6x10 heavy timber framing that is attached to the perimeter 8x18 beams that are kind of in the notch you can see at the top of that section there, and then again into blocking at the center of the roof. So a heavy structure, but again, it's completely, I mean, there is no R value for this roof because it's completely separate of the thermal membrane, allowing air to pass underneath it and shade the entire structure, a large portion of the walls. And you'll also notice here the overhangs on the north and south got much larger than 4 feet, which was in the initial design. The back is 6'7", and the front is 8 feet, 8 inches. So helping out significantly in that regard, and also pitching the roof from the north to the south, which seems a little counterintuitive when you think about the view being to the south. But when you have a 3,000 square foot roof and a site that's sloping from the north to the south, I want to move the water in the direction it's going to naturally go, rather than push it back into a courtyard and then have to figure out how to get it out or deal with it when pipes inevitably clog or riprap and things like that get filled with sand, as they often do out here. So that's kind of why it's pitched that direction. And that's the upper roof assembly for the shade roof. The thermal assembly for the roof consists of a 36 mil fiber type that sits over the top of 1/4 inch Den's deck, which provides my Class A fire rating for this roof, over 4-inch EPS insulation. And then I have an adhero membrane that sits over top of the structural membrane. The blue line you can see here, the standard WRB call out. 5/8 sheathing and 11/7/8 TGI, standard 210 TGIs. And my pitch is created as it's just a shed roof, which is, when it comes to framing and building, is simple. I've got a north wall that's taller than the south, and we put the joists up and continue on with our day. So when looking at the upper roof, before we get into the insulation on the inside, I opted for 4-inch EPS, not because I needed it for the fact that it's an unvented rafter assembly. In this climate assembly, I believe I could get away with R5, but I used the 4-inch for a couple reasons. One, it got me to my 61.7 that I was looking to achieve, and also allowed me the buildup I needed to create an internal drain at the southern edge of the roof. So you'll see that kind of depicted at the southern edge of the roof there, and you'll see another piece of EPS down below on the inside, because as that gutter tapers to the east and the west, you kind of lose that. And I apologize for not having larger details. When I build for myself, I don't go painstaking on big details because we sketch a lot of stuff out in hand, but that's a pretty good depiction of what's happening here. And so that was the reason for the 4-inch. It gave me the pitch that I needed to get 1/8 of an inch from the center of the drain, from the center of the roof out, to get water off the roof when it gets underneath there. Worked wonderfully before we did the shade roof. And now that I have the corrugated metal up, I can imagine that fiber type membrane is going to see only a small amount of water over time, but still successful. And again, the shade roof makes it simpler, as opposed to a flat roof with crickets and things like that, and internal drains, which are not a lot of fun to deal with as a builder, and also increased expense. If we can just move the water off the building on the outside, it's a successful way to manage the project. Now, inside of those TGIs, I've got a layer of R30 rock wool insulation and another layer of R23 rock wool insulation, and then an Intello interior airtight membrane, and drop ceilings throughout. And the necessitation for a drop ceiling as deep as you're seeing here is largely to do on the north side, where you'll see assemblies H and B. That's kind of my trunk area where I have my main return line running, my big bundle of ERV duct work, and also these 3 and 4-inch small air ducts that are distributing the supply air in the house. For the walls, assembly H is sitting on top of the ICF, so that's going to be another 2x8 wall and a 2x4 wall, because those ICFs are about 12 inches wide, filled with R30 and R15. Then I have my Intello and an interior layer of R23 and a 2x6 wall, which is essentially where the windows sit, as you can see here in that. And the east and west walls are a little bit different. The east and west walls are simply an R30, my Intello, and an interior layer of R15, and then a 2x4 utility wall. So we didn't flat frame any of the interior walls. There's a physical 2x4 wall stood up in those sections. As we move down, the footing details with the ICF and the outside 4-inch kind of like wall of EPS that is on the north and south sides butting up against the ICF stayed the same as the original design. I got rid of some of the haunch insulation on there. When they widened the house, an interior footing came about from the structural engineer. And then you'll notice that the slab assembly C is simply a 5-inch slab on grade 2-inch EPS foam and sand, right? So the geotechnical engineer wanted sand and not gravel out here, which was not not the most common thing that I've dealt with in the past. Typically gravel is what we install, but that's what it was. This central detail here ran a thermal bridge calculation on it. And in fact, those kind of haunches of 4-inch by 12-inch insulation stacked up greatly increased the performance down that center. We were losing a lot more heat out of there than you would think. If I was a little bit better, I probably could explain the science behind that, but I can't. I'll leave that up to somebody else. But that's the numbers that we got when we were running those through. And so one thing in regards to the slab that I think is really interesting when it comes to maximizing the R values is we did a little table on where I'd started with a 6-inch to a 4-inch to a 2-inch. And believe it or not, the heating demand and the cooling demand performed better with 2 inches of insulation below the slab. And which is, you know, when studying this, it was pretty common to see 4 and 6 inches below slabs everywhere. Now, obviously, you're looking at a lot of case studies in the Pacific Northwest and the Northeast where people are doing wonderful, you know, passive house projects, have a lot more experience than certainly I do. So you lean into that. But to kind of use the PHPP to walk through and see that this was something that I didn't think was going to happen. I mean, I don't think I have enough experience to say whether I knew it would or wouldn't, but to see it happen in real time was pretty cool. So we ended up with 2 inches of EPS foam below the slab, which as a lot of people I'm sure know, it's not an inexpensive material to purchase. And then again, when we look at this section, I just was trying my best to sit at like an average of an R40 wall because I remember seeing and reading about how once you get above R40, like your return to investment on adding extra insulation and framing and wall depth, and you're losing interior space, goes down dramatically. So that was kind of my target, especially once we introduced the shading aspect into the project and weren't really seeing, you know, cranking insulation numbers up beyond that, helping out this project in particular. So kind of a long way to walk through and to find a way to get this project to certification and tie everything together appropriately, as it were. So that's kind of how I walked through that process of getting here. And it was a really great and fun process to go through. And there was a lot of awesome contributors in that process to learn. So yeah, so now we'll take a quick look at both of the verification pages. So the original one on the left-hand side was what I showed everybody earlier. And then when I take that model and I input the over roof and shading of that over roof, along with a shading reduction factor of 15% on the windows, I get to my 4.25, you know, kilo BTU per square foot year, which I was very comfortable with because it gave me a little bit of leeway if something did change or need to change, or if I had to substitute a system somewhere else in the project that could affect that heating and cooling load, that I would be within that. So where I started, 7.81, and really in Palm Springs closer to 11, to work through some iterations with the PHPP, with the design, with the client, and end up at 4.25 was really great. And, you know, I feel lucky to have the experience to do that and have, I guess, seen some farm structures sitting on the side of a hill to find some inspiration to get there. So that's the journey to where we are currently now. And I'd like to take some time before the end of the presentation to just run through the systems quickly. So there's an 18,000 BTU ducted mini split in this project. We used 1-inch duct board to create the supplies and returns, and used RIA, a 3 and 4-inch small air duct distribution system to provide the supplier through the house, and with the design through DR Nelson as a large mechanical engineer who performed that. You'll see some of the pictures here and the supply plenum that we had to create on site down in that lower left-hand corner, and kind of this trunk that I was talking about earlier with all this ductwork running through the job on the north side. I had just enough room to squeeze it in above that. The ERV is it's by Brink, and that's a Flare 325 ERV for this situation. It took myself and another one of my crew like 2 10-hour days to install this. It's the first time we'd done it. But the installation was simple. And, we were able to kind of get everything clicked in and done. And then you'll see some photos of that's my kitchen exhaust with the 3 ports in it. So really great. It was a really great system to work with. And the client opted to add the pure and duct filter, which you can kind of see in that where it's in the closet, the ERV closet. So there'll be a couple doors put over that when we're all done. So when you walk in, you're not staring right at that thing, although it's a lovely machine to look at. For my makeup air system, I ended with a Fantech 750, kind of a kit package, although I had to get rid of the filter box and the duct silencer because I didn't have enough space in my drop ceiling and above the kitchen cabinetry where I have like false panels above to get in and access these items. But you can see the damper, the filter box, and the blower, which then feeds over the top of that central glulam beam that runs down the house and into a box that we built here that goes down the back of the range hood and kind of blows out behind there. When I was working with the certifier on the project, who's Matthew Bowers of Oros Group, I was kind of racking my brain on makeup air because I'd never installed a makeup air system in a house before. That was just like, all the homes before I'd done were high performance buildings. So it was a new thing for me. And he had suggested seeing this on a lot of projects, which I think is really clever to blow the air out, directly behind the range hood. So when you're turning it on, hopefully creating a circle, and I'm not either pumping cold air or extremely hot air into the house, as opposed to my original idea was just to blow it like out above the linen closet, just to balance the pressure in the house. So kind of a good thing that worked out with our, little range hood insert that we've got here. You can see depicted there. For the hot water systems, we went with a Rheem Proterra hybrid 80-gallon tank. I've installed a few of them in the past, and they're hadn't had callbacks, so that's usually my 2 thumbs up on putting something in a project again. This is a nearly complete installation. We still have some pipe installation to finish, but you can see the expansion tank and the thermal mixing valve, which is a really cool thing to read about. For the controls, we went with Auto Hot USA. And so the 2 bathrooms and the kitchen will have push buttons in them so that you'll push up and the button flashes red until it's hot. That's paired with the Grundfos pump that you see there. And this is located in the ERV room. So it's past the point of the furthest fixture. And I wanted to do that to hopefully, because that's where the sensor is to tell the buttons that the water's hot. So I'm not pumping, 300 feet of water through the line. I'm only going like half of the recirc line and hopefully getting it faster. And when we run the system in the house now, it takes about 2.5 minutes to have that sensor go off, and you have very, very hot water coming through those pipes. So a pretty cool system. Also, I'd never worked with before, but very clever. And hopefully the people who are living in the house can figure out how to use it, or I might get a few phone calls. For the windows, we have Alpen was the manufacturer selected on this project. For the fixed PVC windows, we have the Tyrol PH Plus with Solar Control 6 PH Plus. The tilt glides, which you can see in this upper photo here. Every bedroom has a tilt glide door. And then the 4-panel central one is a Zenith 925 series with a bit heavier glass in that unit. And I think this is also a good picture to kind of show that perimeter beam that the shade roof is essentially attached to and resting on at the front side of the house. And you can see our Hero 3000 and all that kind of good stuff there. So now I'd like to take a quick moment to talk about, there's two homes on this property. One is the passive house, which we're nearing completion on, and one is an energy code home, a California energy code standard construction, not a high performance build. That's on the lot directly to the north. So there's about 350 feet between the 2 lots. They're going to experience the same weather as it is. And so when the passive project is done, we will have the data to be able to compare the usage of electricity and interior temperature versus the outside stuff. And I just think one metric to look at here is, in this 3-bedroom, 3-bath house, the one that's the inside outside have been completed, has a mini split in every room, 2 in the main space. So that's a total of 66,000 BTUs of heating and cooling. Whereas the passive house has an 18,000 BTUs of heating and cooling. And even though my cooling load tab is much lower, it's about 4,300 BTUs for the passive house. When the mechanical engineer was running that through. They were very concerned with the latent load in this house and also some of the severe temperature swings that we've been seeing in the recent years. So they were pretty gung-ho about me putting an 18,000 there. I wanted to put the 9, but I'm going to lean on the people with the experience, because it's certainly not necessarily fully in my realm yet when it comes to high performance homes with a smaller amount of HVAC. Because I think in projects in the past, you would lean more towards what the energy code home here has, which is throw a unit in every room and just make it so we're not, having somebody call us back. They've got enough to control in each room that they're going to be comfortable. And that house, performs well as well. And you can see the solar panels on the top here. And here's 2 photos just kind of down in the south courtyard. So again, the same kind of, the outsides are going to be styled almost the same, and the plaster color is the same. The shade roof construction is a little bit different, but similar there. You can see in the south courtyard, and then the north courtyard, which we're getting close to plastering in currently, but this is a kind of a good shot showing you below the carport roof, kind of shooting back to the southeast there. And you can see the bathhouse shade roof, and then also kind of the north side cantilevered shade roof and that resting beam, to kind of give a good idea of where the construction's at that point in time. And so when doing both of these projects, there's certain things with the energy code that you have to deal with, but I didn't have too many troubles kind of integrating the California energy reports and energy code in terms of the passive house, with how insulated my walls were, and especially the roof. It certainly helped me out. But it was surprising to me that when looking at their standard mix, like it is said to not perform much better than the prescriptive standard, which take that for what it is. At the end of the day, when the projects are done, you'll be able to compare and see. And we're going to have one that's an energy code home that doesn't have an airtight membrane and a bunch of AC in it, and then enough solar panels to offset their consumption of energy, I suppose, and then a passive house. So you can think about the numbers and all those things, but in the next few years, as we compile the data between the 2 projects, hopefully we'll have enough data set here to really kind of drive the point home that building to passive house standards is much better than a code home, and prescriptive standards aren't always the best approach, although it's good. I mean, I think it's a step in the right direction, and hopefully that's the case. And who knows, maybe it's not. I don't know. I mean, you never know. We got to kind of put it all together and see what it is. So at this point in time, I'd like to say that's the end of my presentation. My name is Trent Lawton. I work at Not Architecture and Construction, and happy to field any questions that anybody has, or field further questions in the future. I don't know. So that's the end of my presentation. And here's a aerial shot from the other house looking down over the passive house, kind of give you a good idea from the north looking south of what we were out there going with. So that's pretty much it for me.
All right, great. Trent, thank you so much. That was a fantastic presentation. I see we have a couple questions in the chat. Let's see. Robert Haas asks, the airspace between shade roof and real roof is 8 inches.
It's about, 9.5 to 10, because I've got 6x10s, which come out at about 9.5. Although, as we're finding out here, for heavy timber, if I need something to end at 2 inches, I'm ordering it milled at 2.25, because when we set it on stickers and let it acclimate out here, the wood will shrink at least 1/4 inch. So I would say 9 inches would be the airspace that would be between that, and plus the purlin. So, depends on how you add that up. So 9 to 11 inches would be, the area between.
Great. Question from Dave. Do roofing penetrations extend through both main roof and shade roof?
They do not, no. They go up into that area. There's access to them, so we cut access panels in that corrugated roof. So I can get to like the ERV stuff and the plumbing vents and anything else. There's really not a whole lot of penetrations. I try to group, especially when we're doing plumbing. I mean, if I can get 3 or 4 vents together, despite the plumber looking at me, the plumber works for me, but it's easier just to shoot the pipe straight up. But if I can, the less amount of penetrations, the better. So there aren't a whole lot, but they do live below the shade roof.
Great. Let's see, question from Alice. Just curious, even though there is a roof insulation, does the airspace between roofs act like a drum, creating amplified noise when it rains, for example? Are there any potentially negative concerns, like roofing maintenance or impacts to Wi-Fi?
As we haven't occupied the property yet, I can't say that for certain. I do know noise won't be an issue. It has rained pretty substantially since we've been here, and you can't hear it on the inside of the house. Certainly when you're sitting out on the north and south patios, it's a very romantic, patter of rain on the roof. But we haven't fully done that. I mean, I lived at the job site and still live on the job site. So I've been here for all the weather and seen everything that can kind of happen during the night and during the day out here. And I think Wi-Fi issues come more from the fact that just the Wi-Fi goes down and the cell service goes out. So thank everybody that I actually had a consistent Wi-Fi connection out here all day today.
Yeah, we are very grateful for that. Question from Tom, do you use future weather files? Which ones, if you do?
I don't. I think like for this project, when I got connected with Matthew Bowers through Tad Everhart at Certifiers Cooperative, and we were working through like the data set for Yucca Valley would be all I've gotten. Now we've collected some data out here, and then when the job's done and connected to Wi-Fi, we will be putting like a weather, like a smart weather vane on the roof. So we'll be able to see what the weather is on a daily basis and start to compile that over time. So we will gain that data. During the construction, I have a hotspot that I work off of and live off of, but no consistent internet out here. So it wasn't really possible to have a more advanced system to be collecting, but I have not used or am familiar with future weather files.
Question from Bronwyn, do you have an approximate cost difference between the code and passive house? How different?
I do, and I think I need to break that down a little bit better because I kind of have to pull the two spreadsheets apart. I think within looking at this project, when I look at like the mechanical systems, those are a little bit more for the passive house just because of the ventilation system. But when you go from such a small system to that, those are comparable. I think items that are a little bit more difficult to compare would be the extension of the shade roof over the entire project. And certainly have breakdowns on those jobs. So I think out here in this environment, if you were going to go from a standard house with no shade pergola roofs, it's hard to compare that as a perfect thing. But that is also certainly data that I'm going to be happy to share with everybody when the jobs are done. And I have done some comparisons across. But when we're talking about framing and the fiber tight roof, and then obviously the HVAC things, I mean, a lot of that's coming out the same. Adding a central portion of the shade roof, which you saw on the aerial. If I go back a few slides here, you can see like the center of that roof is out, and that was a cost savings thing for the client. Also lowered them down. I have to cover the whole roof for the passive house, so there's an added cost there. But when I have more finite information on that, I'm happy to share that with everybody. The cost per square foot, how we did everything out there, and I work with a small crew. There's only 5 of us that built both of these homes, and we do everything from foundation work through framing, waterproofing, window installation. I have a plumber that works for me. There's an electrician on the crew and an HVAC guy. And we all do a little bit of everything, but everybody kind of has their specialization. So I'm happy to share the labor and the cost and stuff like that. I don't have all that prepared for this presentation, unfortunately.
Yeah, of course, we're going to have to get you to do a PHN case study. I'll bother you for that later.
Okay.
Let's see. Tom asks, regarding the shade roof, is high wind an issue in that area? What wind speeds can that roof handle?
We are at, I'm gonna have to look at my plans. I think it's funny when I did that, and I talked a lot to the engineer when we were especially floating it out as far as we did. They weren't overtly concerned, or the engineer was not, but I believe I'm at like I'm trying to, I apologize. I got my plans in front. I'm trying to get to the notes page in the structural so I can answer that. Let's see. 110 is the ultimate wind speed. The nominal wind speed is 85. My exposure is a class C with a horizontal pressure coefficient of 18.9. I will say we have been here building when we have had sustained winds of 60 miles an hour with gusts up to 85 and to 90 miles an hour. We weren't working on those days. I mean, we tried to in the morning, but that gets shut down pretty quickly. So the wind does blow a lot out here, and certainly those shade roofs are, it's kind of a parasail, but I mean, it's fully engineered, and that's certainly something I got to lean on the engineer for. They said it was okay, so we built it.
All right. And then also with regards to the shade roof, do you think having high reflectance would help more? And since the lower roof is protected other than from horizontal forces, rain, what kind of minimal protection would suffice?
I think the reflectivity of the roof was certainly something I thought about when selecting it. And knowing that I don't really need to achieve the cool roof at this point, I opted for the rust roof because when it just blends better with the environment, like when you're up on the hill looking down, it's hard to see this house because it just kind of blends. So I think from a design standpoint, that picked it off. I don't know if I was overtly concerned about the radiated heat from that. The lower fiber tight roof is a reflective cool roof, right? So that would be getting through to my code. And whenever I do a pitched roof like this, I always push the client to go for a roof like a single ply, and fiber tight's a system and with a company that installs that for me, that I've done on multiple number of projects. You can get a 25-year no dollar limit warranty on the roof. And then certainly having the shade over roof on there, I'm anticipating getting a pretty very increased lifetime on the fiber tight, and probably sometime in the next 30 to 40 years, we may have to go out and start replacing some of these panels. As they start to leak, it's going to fall down to another thermal barrier that's not getting hit by the sun and worn out by the sun. Because as anybody knows, UV is a huge thing, especially with building paper and roofs and all that kind of stuff. It's what eats away. So I'm hoping that by covering this roof in this way that, you could hopefully look and tell the client with that extra investment that you potentially have a roof that you may have minimal repairs over a very long lifetime. But again, I'm really young, so I don't have a ton of experience in this. And this is certainly something I've never built before. So something to look at over time and just keep track of, like same with the energy data in the house, and just see how this performs. I don't know. I think you go into things with the best intentions and try to think it out. But, I've built long enough to know that things are far from ideal in this world, and your best laid plans hardly ever work out exactly as you want them to.
At passivefastcal.org, you can sign up for the newsletter. You can sign up for memberships, an organization, company membership, sponsor, or volunteer. So thank you very much for your time and attention. If you want to reach Passive House California, you go to info@passivefastcal.org. And thank you very, very much, Trent. Well done. Now we can, is for people who are staying, if we want to keep asking questions, if you can stay, Trent, we can do that.
Yeah, absolutely.
Those questions. So John asks, is there a cost estimate in energy savings versus code homes over a 25-year time frame?
I mean, I certainly wouldn't have that information. I think I would hope to be able to produce that over time. We've had the code built house done enough that I know what they use in some of the heavier summer months. I don't have that data in front of me now, but I think that's certainly going to be a very important part of this. That's the driver of Passive House. I think I'm very lucky to have been able to be a part of a project with a client that's willing to invest to make something really great like this, which is not super common. But at the end of the day, you can call it what it is. There are homes in the desert that people will live in for a portion of the time, but they will also be renting these out. And so it's great experience for me, but I'm certainly not saving the world here by building these two homes. And hopefully over time we can get some data that could help that out. But long story short, the cost is always that aspect. And I think to be able to garner as much data as I can over time and present that and be open with sharing that, I would hope that it could help in some way, and hopefully jumpstart my career from going to build fancy, nice homes for people that aren't energy efficient to doing Passive House projects, and also being able to participate in projects that have tighter budgets and maybe in areas that the climate isn't so extreme. But I think you go back and look at look at the farm structures I showed, right? I was asked to kind of tie something architecturally to the house, but realistically, you could put a mobile home out here, put a farm structure over the top. Maybe not a mobile home, but like a Passive House mobile home, and you may be able to achieve the same performance and not be spending that, the investment that was put into this project. So Yeah. Long-winded answer, apologies.
Martin asks, is there a concern for debris accumulation or birds nesting in light of the relatively tight cavity?
Debris, I'm not supremely concerned about because there are no trees around here and there will be no plans to plant large trees around, and it's up so high. Birds is always a concern. Now, we don't have any yet, and the other house we finished the inside and outside and got C of O on the code house in January, with similar niches and areas. Obviously, with the roof center cut out, like you saw in the aerial view, it would be easier to access and clean. But I think yes, I think, you know, being a builder long enough to know that like I can never make a guarantee on anything. You know, I think we go in with the best intentions, and could I clean it out? Yes. You know, but long enough telescoping pole in between those areas, I could probably get far enough up in there to pull something out. But I'm not overtly concerned about that at this point in time. But it could be a problem, and I may have to come back and address it.
And last question from Megan, can the over roof tolerate an infrequent snow event?
It's certainly rated for this area. And again, that's all kind of passed through to the engineer. Now, I think the most frequent, or the most recent, and this was before I was here, was back in 2018, where they had, I think, 18 inches of snow in Yucca Valley and about 4 inches down in Morongo Valley. Since I have been living and working out here, when we had the heavy winter where the mountains, I know people who were living in Southern California would know that like parks were closed and like Lake Arrowhead and people were stuck in their houses. We got, you know, about 1 inch of snow a couple different times, but that was the most I ever saw. But certainly given the climate area, I would say the engineer would have that covered. Also, when you're building a 6x10 over roof and you're carrying those things around and looking at it, not to say that means it's going to function over time, but it's a very substantial roof. And I certainly worked with the engineer as much as I could to try to make it less, because every time you jump up in that lumber size, the cost does increase quite dramatically. But that was what was decided on for a number of factors, both the shear value and also, you know, future weighting of the roof.
Wonderful. Yeah, thank you so much, Trent. I think that is that's all the questions. But thank you again for your presentation and for sticking around to answer all of our questions.
Absolutely. Thank you so much. I'm glad everybody took the time. Thank you. I don't get to present or talk to many people about this very often, so very exciting for me to get to do it. And there's a lot of great, bright minds out there, and people that I've seen presentations on. And it's just been pretty interesting to be invited into this community and starting through the Passive House Accelerator, meeting Christian and Cyril at the SB9 house in Culver City, which tied me into the exterior Venetian blind system that Cyril is providing for this house. And just, yeah, it's been really nice, because I think before, where I worked before, everybody worked in a silo very much, and there wasn't this kind of community to tie into and to learn from and be able to present to. I could say a couple of years ago when I was taking my exam, I would have never imagined that I would ever be presenting a project to Passive House California and actually having people sit through the whole thing and listen. So I appreciate everybody's time and the opportunity for this.